So today I'm going to be talking about how to match AI to some real world problems you might see with your clients. Is this up?
Yeah,
Technical difficulties, sorry. So from Prashant, you just heard about some ways that you can be a top tier, better consultant. So I'm going to be talking about one specific way that you can start thinking during your meetings and new solutions you can offer your client if there is space for them. So to begin, I'm going to start with a motivating scenario and some questions that I hope to answer for you today or to help you guys answer as they come up. So let's say your client presents you with a business problem. The questions I would like to consider today are, after considering traditional solutions to this problem, would AI be a good solution? And if AI is a good solution, what kind of AI approach would be best? So to answer these questions for you today, I'm going to be going through 4 example problems that may come up in the real world to help you guys kind of understand what kind of solutions would match those problems best. So I'm going to try and keep the explanations of these problems really simple, and leave time for questions at the end if anyone has any. Yes, okay. So without further ado, the first problem. Searching. So let's say the client has a large database of important scientific documents of different categories. So they would like to be able to find the documents they're looking for easily. So to solve this problem, first you want to consider what you have at hand. So the data you have available. So first you've got all of the text content in these documents, all unorganized. You don't know what's in it, you just got the text. And then you've got the search query itself. So it could be something like genetics paper, right? So the solution to this problem, as it turns out, is clustering. So here I've got this nice diagram for you guys to kind of show how this algorithm works over time. It's a nice picture. So what it does is, obviously you start out with all of these uncolored dots, and then over time it slowly breaks it out into all these different categories, using an algorithm that I will not go into very high detail over. But essentially the task is to group the data into categories based on how similar they are, and then find out which group or category that the selected object belongs in. So to go back to the example, the data to be categorized, all these green dots in the beginning, are all of the documents, all the text content.
Do you have a different USB spot?
Yeah, I'll try. Sorry about this, guys. Okay. All right. Much better. All right. So you've got the data to be categorized. In this case, you've got all the different documents and you've got all of the different categories. So imagine these are all based on topic of the document. So you've got genetics, botany, zoology, and then you've got your selected object, which is the search query, in this case, genetics paper. So now once you have these groups and the algorithm, the AI has like figured out what belongs in what group, all you have to do is show the user all of the documents from the group that the search query belongs to. So I mentioned the AI groups things on how similar they are. Now, how does it know what is similar? So in this case, for text, you use this thing called cosine similarity. So how that works is the AI converts every document's words into a vector. So each word becomes a vector, which is just like a line representation. It's a bunch of math, but essentially here's a pictorial representation. So say this red line is the word cat and that is the word dog. Then you want to check how similar the vectors are. So that's where the cosine similarity comes in. So in this picture, it's about like how close the vectors are to each other. So words that are close in semantic meanings are going to be really close like that, and words that are slightly different will have larger angles between them. Right. So the advantage of this over, like, say, full text search or a more traditional search method is that it preserves semantic meaning. So we're not just looking for the word cat. You can look for any word that is similar to cat. So like kitten, lion, any pet. So second problem. Oh, before that, any questions on that? All right. So moving on to the second problem, which is recommendations. So in this case, let's say the client is an online retail site. They have a ton of products on their website, but they want to show their users similar products based on their past purchases. So say like Amazon, you've seen that little bar below that shows you stuff based on what you've purchased in the past. So how does that work? In this case, you've got the user's past purchases as data available and all of the items listed on the site. All uncategorized, you don't know what they are. You just got all the items. So in this case, the solution is also clustering. So now the problem's kind of familiar. It's going to group the data into categories. In this case, the data is going to be all of the items. So it could be categories like kitchen items, lighting, home furniture. And the selected object is going to be the user's past purchases. So once again, once you find out what categories the user's purchases belong in, you just have to give them all the items from that category. Any questions on that?
I do have a question.
Yes.
I mean, both first problems are related to clustering.
Mhm.
I don't know if this is the context of the presentation, but how do you achieve that with a model that just send prompts? But how do you achieve clustering?
So you can. So a model that sends prompts, different kind of model. I will get to that in the end. But this alone is an algorithm on its own. It's a clustering model. So what we're thinking of, like prompts like ChatGPT, it's a different kind of model, and their task is kind of slightly different. But we'll get to that. I'll get to that. All right. So problem 3. So in this case, let's try some fraud detection. So the client is a banking site, and they want to be able to flag transactions as fraudulent or not. Once again, we'll consider what we've got at hand, which is the incoming transaction, and then all the existing transactions in the past, but we know whether they're invalid or valid. So in this case, your AI solution is going to be classification, which is very simple. As you can see, this is a diagram of what's going on. So all of these dots are the past transactions. And this black line that's being drawn here, that's a hard and fast rule. It's very simple. Blue, valid. Red, invalid. The task is just to figure out where to draw the line. As you can see, this line is shifting over time. It's because the algorithm is constantly updating where it thinks the best place to draw that line is. But once you have it, all you have to do is once a new transaction comes in, figure out where it goes, on which side of the line. So following the example, algorithm draws a line for all past transactions. New transaction comes in, just figure out what side of the line it's on. All right. Yes, question.
How is that different than a cluster of 2?
So in this case, with classification, it has to do with your data. I will get to that, but essentially in this case, you know which transactions are valid and invalid. In the clustering problem, all your data, you don't know what it is. It's just you got it, you don't know anything about it. So you already have the labels in this case, but with classification, you're trying to discover the labels for your data. So problem 4, predictions. So let's say your client is a housing mortgage company and they would like to predict the housing price for a house over the next 5 years. So in this case, the data you have available is all the information about houses sold by the company over the past 10 years. So that could be stuff like the price, the square footage, the number of beds and baths, location. So you've got these 4 attributes about each house that they've sold. In this case, the solution is regression. Now, this picture does look familiar, and I'll get to that. So in this case, I wanted you to think of this picture as like a graph. The task is, again, to figure out where to draw the line. Now, if this is almost exactly like classification, is because it is. Because the algorithm under the hood works exactly the same. Classification is, to answer Jeff's earlier question, is what side of the line am I on? So you're really looking for a label, and for a more technical term, we call that kind of data discrete. So we want yes or no, true, false, something like that. Regression is according to this line. if we're looking at this as a graph, what's the value on any of the axes, whichever one that we care about. So in this case, it's house price that we want to know. Based on what the square footage is, what is the price, is the question we want to answer with this picture. So in this case, the goal is a probability or what we call continuous data, so numbers, so any kind of numeric value. So I'm just going to follow through with an example. Say we've got an 800 square foot house, 1800 square foot house. And we've got this line now, the algorithm's done. For a new house, we just want to figure out where, just follow the line to find out what its price is. So for an 1800 square foot house, we kind of map to that line, and then we see that it has a $650,000 price. So I may have mentioned 4 variables in the beginning. This is just 2, right? So we've got house price versus square footage, because this is a 2D graph. This is easy to picture. But in practice, in reality, I talked about house price, I talked about time, I talked about location. All of those variables are going to be their own axis. So it's hard enough to perceive 3-dimensional space, but like imagine like 64-dimension space. I would like to spare you guys that visual, so yes. So this is just a very simple breakdown of how the problem works. So to sum up, any kind of recommendation or optimized searching problem that you're presented with, clustering is probably going to be your best solution, especially when you don't know anything about your data and your goal is to kind of discover information about it. Any kind of identification or decision making on whether something is present or not, that's classification. You just want to assign, like, pin a label on something that you already know. That's classification. Any kind of prediction is going to be regression. So your housing price, stock prices, anything like that. Now to go on to Raul's question. So I've been talking about all these algorithms. How do they fit into what we know as AI? So ChatGPT, Claude, and all of our lovely LLMs. So ML is AI because it is the foundational building block of how these chatbots work. So where is the intelligence in this? So it's how it learns continuously over time based on the mistakes it's made in the past. So all any AI algorithm does, or ML algorithm does, is do some task with some inputs, find out how wrong you got. Usually all these algorithms start out with arbitrary values. They just pick some random thing and then they find out how wrong they are, update the inputs based on the error that it got, and then do the task over again, see how wrong you are, do it over again, update, and rinse and repeat until the error is small enough or the person that's programming it is like, okay, you can stop now. Your result is good. So what about ChatGPT? So ChatGPT, along with Claude and all of these other chatbots, are what we call LLMs. So that is a different class of model than what we've been talking about. So essentially, they all fall under an architecture called GPT, which is a generative pre-trained transformer. Now, lots of big words, so I'm going to kind of explain them simply. So the word generative, meaning it makes new stuff as compared to presenting existing data. Pre-trained, so the moment you open a ChatGPT or Claude, it comes out of the box already having learned some things. It's not starting from scratch when you give it a new prompt. Now, this is the real kicker. This is the word transformer. So back in 2017, Google published a paper called Attention is All You Need. And it was a groundbreaking paper that kind of laid the foundation for what we call the GPT today. And that is what all of these LLMs are built on. So a transformer is basically a big combination of all the techniques I just went over earlier. So specifically classification and regression, just layered one on top of each other to increase accuracy. Now, it does get very complex if I were to talk about how exactly they're layered and all the math that goes into it, but feel free to ask me more if you're interested about the paper. All right, any questions?
So use of AI for all this, like, classification to studying problem, is it ongoing or we use AI to come up with algorithm or like similar to algorithm, and once we have that, like we no longer use AI.
So your question is whether we're using AI to come up with
Ongoing basis, so basically every time you need to search, you always use AI.
Mhm.
Versus like you use AI to generate, you say, program based on specific algorithm that it identifies. And like then at that point, like we stop using AI.
So it really depends. It should be continuous because as you see more data, the longer you let the AI learn, the better it's going to be. This is like standard. So you could stop using it and then your algorithm is only going to be so accurate because you never stop receiving data, right? So it's really a choice. You could stop using it and you know, work with whatever the AI has learned so far. But that's the thing with Claude and Gemini and Google and everything. If you they do collect your data, right? We all know this. So that's why it's so good. It's because it's constantly learning. Yeah.
So in the interest of business, for clustering versus classification models, I could see how it'd be a lot more expensive to make a classification model because you need a lot of labeled data. But
Mhm.
for clustering, I mean, you already have an embedding model, you just throw a text at it and then cluster based on that.
Basically.
How much more is there trade-offs between using clustering and classification where classification is too expensive to solve the problem versus clustering isn't the right solution for the problem?
So I don't know about cost personally, but both of them are not very complex math-wise. They're about the same amount of complexity. But it's really about the data that you're working with, right? What you have right out the door. Sometimes in the transaction problem, you already know which transactions are valid or not. But with clustering, you really don't. You're trying to discover that. So in theory, you could like cluster first and then apply classification on top of it if that's what you wanted. But it's really about what you've got right out the gate, what you're working with.
If you're gonna do classification, how would you ask, or what do you ask the client, or how do you know to ask the client how much data you have to make it accurate? Like, what are some of those questions that you want to ask a customer?
That's a great question. I'm not entirely sure. I think it really depends on the problem. So when, say you're in the, let's go back to the banking problem. You kind of think about what you, once you start thinking about how to solve that problem, you kind of think about what kind of information that you need. And if it's really about what the client is comfortable offering you. If they're not comfortable offering all of the transactions, then you might have to do clustering first because you want to arbitrarily label the data if they're not comfortable giving you that information before, and then apply classification to get your desired result.
Is it typically like in tens, the hundreds, the thousands?
So
Or does it depend?
So the rule is the more data, the better the algorithm. So yeah, the over 10,000 is usually very, very good. But that's also more computationally expensive. So all these trade-offs do happen. So I personally can't speak to how exactly you would implement these solutions in the real world if you do decide that this is the solution that you'd like to proceed with. But yes, the general rule of thumb is more data, more accurate, more learning time, as in more iterations, more runtime. The more it sees more data, it gets better. Yeah.
So I feel like there's a threshold between, you're familiar with the term garbage in, garbage out.
Mhm.
If you walk into a client's opportunity
Mhm.
and you don't know how high quality their data is, you don't know how accurate it is,
Mhm.
there's going to be a threshold where an AI solution would be a good solution,
Mhm.
depending on how good quality or depending on the quality of the data,
Mhm.
versus it would be a terrible solution because the data is terrible. If you build an entire AI solution and it ends up being horrible because you didn't understand how good or bad data was, how do you avoid that situation?
So typically before we apply any of these AI solutions, if we were to, you would want to do something something called data cleaning. So if you guys have done the AI training or remember this fun term called dimensionality reduction. That is one of the data cleaning processes we do to kind of extract the most important data, get rid of the bad data. You can't really speak to accuracy of data since you can't really see everything. But yeah, generally before we run a model on it, we kind of optimize the data to make sure it's most accurate. But like, if the client just has wrong data, then there's not much we can do.
So, let's say you have a problem and the client just gave you a small set of data.
Mhm.
And then let's say you do let's say classification, right? If you like do as you go on and grow your data as you work with a client, does that model change based on the how will you grow on that? How will you solve the problem as the data increase as you go by?
Well, yes, that's
Because you get more data, probably more fields on it. So is it just like one model as you go on along, or does it changes as or what the data is?
so that's a great question. So it is the same model, so the same strategy, the same algorithm, where if it's clustering, it's still going to break stuff up into categories. If it's classification, it's still going to try and draw a line. But what changes is we have these things called hyperparameters for each algorithm. So based on the size of your data, you might want to tweak those hyperparameters, and that just changes that just optimizes the algorithm for the amount of data it's receiving, but it's still the same strategy. So if we're going to take the example of clustering, right? One of the hyperparameters is the number of clusters. So you could set it higher and higher based on if you get more data. Or you could increase the number of times the algorithm runs before you tell it to stop. So those are some of the things you could optimize. And I'm sure like if you were going to use this in a production real use case, those hyperparameters will be configurable for your model.
Is the assumption here that for these solutions, the customer has to have its own model trained on its data to do the inference, or how does this work?
Yes. So if your question is whether you're going to be building a model from the ground up with the customer's data, the answer is yes. But I'm sure from what I understand, there are tools out there today that already have this framework built out for you, and you just have to feed the data into it and set those configurable hyperparameters and see how it performs over time. So you won't have to do any of the actual coding of the model yourself.
So I'm trying to understand AI, and so I thought like I got it, but like based on this question, like I thought like in machine learning you start with a clean state, while like AI like it's pre-trained for like wide variety of problems, and like machine learning is focused on a single or group of problems. Like, is that statement accurate or like?
So AI, artificial intelligence, I feel like if you were to draw a graph, right? AI there would be like supersets. AI and machine learning, same thing, but the thing is ML algorithms, they're all into how to put this.
It's a subset of it.
Exactly. All, yes.
And what people call AI is not AI. They call GPTs AI. They falsely label AI as ChatGPT is not
AI.
It is implementing AI.
The term, what we understand to be artificial intelligence or AI is very like, we have a different definition for like popular, in the popular lexicon, but technically AI encompasses all of these algorithms. GPTs and LLMs are one part of it, but ML is also.
So like depending on problem, like can use different solutions like.
Exactly. So there's like you can look at it as different types of AI.
Like more targeted, where you select okay with this specific for solving the problem.
Exactly. So your GPT is very complex. So ML solutions, like just one of the, it's very simple, the simplest building block that you can have. But the GPT, many of them stacked on top of each other. Very abstracted, which is why you have a chat interface.
Yeah, just agree, before we go, I really like the data questions, and I think one of the things that we can bring tremendous value to our customers is doing that data analysis up front. So when you said you can't tell if it's good quality, you actually can go look at the database, and you, as the engineers that built the system, know what's supposed to be there. And if you see one column is always null, or one column is always false, or one column is always 9999999, you can be pretty sure it's not good data, right? So
Yeah.
part of what we can do is fix the systems to make sure all the data is being stored properly. And then that way, no garbage in, good out, right? So I think that's the value upfront that we can really provide, is understanding the data, making sure it's high quality and clean. And then, from there, sometimes you don't have enough diversity of data. So I think that's another concept, is if you have all one kind of set, it becomes very difficult to build a model. But if you have mortgage data of all different houses, that's great. But if all you have is 500K houses and 10,000 of them, it becomes very difficult to build that prediction.
So you do have this thing called bias, if that's a term all of you have heard. Yeah, that's what happens when your data is a little bit too hyper specific. Say all your houses are only from the Herndon area, but then one comes in from like West Virginia, it's not going to do very well with that prediction.
Great job.
Yeah, thank you.